Good morning all, I am Mahin Fatima studying CSM in Srinivas Ramanujan Institute of Technology. My data structure assignment topic is queue operations with examples. Let's go into the topic. First, queues. Queue is a data structure. It is an abstract data type or linear structure in which the insertion and deletion operations are performed based on FIFO, that is first in first out principle, which means that element inserted first will be removed first. In a DQ data structure, in a queue data structure, the insertion operation is performed at position, which is known as rear, also called as tail, and deletion operation is performed at a position which is known as front, also called as head. As we can see in the figure, insertion is done at rear and deletion is performed at front. Like example, queue after inserting the elements like 25, 30, 51, 60 and 85. After inserting these 5 elements, we get the list as first 25, 30, 51, 60, 85. As queue follows first in first out rule, so element inserted first will be at first position. Next, operations on queues. We have 6 operations on queues. Insert, also enqueue. It helps to insert an element X at the rear of the queue. Second, pop or delete or dequeue helps delete an element X from the front of the queue. Third, traverse or display. It visits all the elements in the queue. Fourth, is empty. Returns true if queue is empty. Is full. Return true if queue is full. Peek or friend returns the value of first element without dequeuing it. Let us go in detail. Let us know in detail the operations on queues. First, insert. Insertion, also called as enqueue. To insert an element in the queue, we follow the following steps. Step 1. Check whether the queue is full, that is rear equal to size minus 1. Step 2. If it is full, then display queue is full and terminate the function. Step 3. If it is not full, then increment rear value by 1, rear plus plus, and set queue of rear equals to value. Algorithm for insertion. Void insert integer value. Step 1, start. Step 2, if rear equal to size minus 1, then display queue is full. Step 3, else if front equal to minus 1, then front equal to 0, rear plus plus, queue of rear equals to value, display insertion success. Step 4, stop. Like example, if we enqueue element 5 in this given list, as we know insertion is done at rear, so 5 element is inserted at rear position, that is 1, and we get the list as this. Next, second operation, delete or dequeue. To delete an element from the queue, we follow the following steps. Step 1, check whether queue is empty, front equal to rear. Step 2, if it is empty, then display queue is empty and terminate the function. Step 3, if it is not empty, then increment the front value by 1, front plus plus, then display queue of front as deleted element. Next, algorithm for deletion. Step 1, start. Step 2, if front equal to minus 1 and front greater than rear, then display queue is empty. Step 3, else display deleted queue of front if front equal to rear and front equals to rear equal to minus 1, front plus plus. Step 4, stop. Example for deleting the element. As we know, deletion is performed at front position, so the element 40 at front is deleted or dequeued, and we get the list as this. Next, display. To display the elements of the queue, these are the steps. Step 1, check whether queue is empty, that is front equal to rear. Step 2, if it is empty, then display queue is empty and terminate the function. Step 3, if it is not empty, then define an integer variable 1 and set I equals to front plus 1. Step 4, display queue of I value and increment I value by 1 I plus plus. Repeat the same until I value reaches to rear, that is I less than or equal to rear. Next, algorithm to display. Step 1, start. Step 2, if rear equal to -1, then display queue is empty. And step 3, else display queue elements are front if the condition for I equals to front, I less than or equal to rear, I plus plus, display dequeue of I. Step 4, stop. And to display the elements, we have this after insertion and deletion. Next operation is empty. If front value equals to -1, then return true, means queue is empty. Else return false, that means queue is not empty. Next operation is full. Check if front value is equal to 0 and rear is equal to capacity of queue. If yes, returns true. Otherwise, return false. So these are the operations on queues, and with some examples. Thank you for giving me this wonderful opportunity. I hope you found this video insightful. Have a nice day.